On average, the Earth is hit once every 2 weeks by an asteroid measuring a couple of meters or so across. In fact, the Earth is being hit all the time by small meteorites, but luckily most of these small objects burn up in the Earth's atmosphere, appearing to us as shooting stars. However, as it was shown by the Chelyabinsk asteroid in 2013, there are larger objects out there that are big enough to pose a serious threat to those in the vicinity of an impact, but small enough to go unnoticed until they actually hit the Earth. Then there are the monster planetoids, as much as several hundred kilometers across, that if they struck the Earth would sterilize it of all life. Luckily, these massive objects are very few and far between and well away from us. The biggest risk comes from the ones up to several kilometers across. But now, for the first time in Earth's history, we humans have reached the stage where we can now do something to protect ourselves, which is just as well because the next big asteroid could have our name on it. Between 2000 and 2013, there were 25 asteroid impacts with blast forces ranging from 1 kiloton to 600 kilotons. 8 of those were equal to or greater than the Hiroshima atom bomb, which was equivalent to 16 kilotons of TNT. Of those 25 asteroids, only one was detected just 19 hours before it hit the Earth. It's estimated that there are some 500,000 asteroids in our solar system classed as near-Earth objects on potentially Earth-crossing orbits, which, if they struck the Earth, would have a blast greater than 10 megatons of TNT. On October 31st, 2015, an asteroid about 600 meters across passed 486,000 kilometers, or about 302,000 miles from Earth. Now that might seem like a long way from us, but in astronomical terms, it's close. More worrying was that for such a large object, it was only discovered about 3 weeks before it was due to pass by. These potentially hostile objects, or PHOs as they're also known, don't need to be hundreds of meters in size to cause us a major problem. The Chelyabinsk asteroid, which came to us completely out of the blue, was only about 20 meters across. It exploded at a height of 100,000 feet with a force of 500,000 tons of TNT, about 29 times that of the Hiroshima bomb. The shockwave damaged 7,200 buildings and injured about 1,500 people, mostly from flying glass and debris. In 1908, it's believed that either a comet fragment of about 170 meters across or an asteroid of about 50 meters across exploded between 15 and 30,000 feet above a sparsely populated area of Siberia near the Tunguska River, with a force of between 10 and 15 megatons of TNT. That's about 1,000 times that of the Hiroshima bomb. That was enough to flatten 80 million trees over an area twice the size of New York City. As the saying goes, forewarned is forearmed. The more time that we have from detecting a possible threat to it potentially hitting us, the better our chances are. Detection is the key here, and it's also one of the more difficult things to do. Even large asteroids are difficult to find. They are formed in the inner solar system from the same rocks and dust that created the inner planets, and many are believed to be effectively just piles of rock loosely held together by gravity. The problem with these objects is that you are looking for a cold, dark lump of rock against the cold, black background of space. Up until recently, the only way to find these large objects was with a telescope and a clear sky, with both professionals using robotic telescopes and amateurs looking for anomalies in the night sky which could be a new unknown asteroid. So far we have discovered about 90% of the really big planet killers, but only about 10% of the 140 meter ones and less than 1% of the 40 meter ones. The 140 metre size is chosen because that would be the equivalent to a 100 megaton explosion if it were to hit the Earth, and the 40 metre ones are equivalent to a 10 megaton city killer like the Tunguska object. In 2012, a space telescope called Sentinel was proposed by the B612 Foundation, a group dedicated to protecting the Earth from asteroid and other near-Earth object impacts. Sentinel is designed to look primarily for objects larger than 140 metres and is designed to find and catalogue 90% of the large asteroids within its mission life of 6 to 10 years. When placed in an orbit between the Earth and the Sun, and with its camera facing away from the Sun, it will be able to detect the tiny amount of heat or infrared energy reflected from the Sun by asteroids compared to the cold, dark background of space. Sentinel was due to be launched in 2016, but due to delays in funding, it has now been delayed until at least 2019. In 2013, NASA announced that it would recommission the Wide Field Infrared Survey Explorer, or WISE space telescope, to look for near-Earth objects. NASA also has plans for its own space telescope specifically for asteroid detection called NEOCAM. If the project gets the go-ahead, it will be ready to launch by the end of 2021. Most of the near-Earth objects have orbits which can be anything from several years to several decades. This can give us plenty of time, providing they can be detected early enough. But what could we do if we did find an object on a collision course with us? There are basically two options: deflection or fragmentation. Deflection only really works if the object is a long way from Earth. We could send a satellite to intercept it, and then, by either landing on it and pushing it with rockets, or maybe even crashing into it at high speed with a kinetic impactor or basically a heavy spacecraft. The theory is that even a tiny change in the object's course at these huge distances from us could alter its course away from Earth. The second method, which many people will have seen in films like Armageddon and Deep Impact, is to blow it up with a nuclear weapon. Although in real life, blowing up a large asteroid could be almost as dangerous as leaving it intact, because it could result in thousands of city-killer-sized rocks or bigger raining down across a large area of a planet. The favoured way to use nuclear devices is the standoff method. The plan would be to explode one or more nuclear devices at a standoff distance of say around 30 meters or so from the asteroid's surface. Not so close as to break it up, but close enough to vaporize the surface to a shallow depth. This would create jets of material as the surface vaporizes, which would then act like thrusters pushing away into a different trajectory. Again, this would only work for an object that was detected well ahead of time and a long way from Earth. A NASA study in 2007 concluded that using nuclear devices to push an object off course would be between 10 to 100 times more effective than the kinetic impactor or push method. This has been backed up by modelling such an event on the CELO supercomputer at the Los Alamos laboratory in 2011. If, however, an extinction-level object greater than 1 kilometre across or a comet were found to be on a collision course but with only a few months' notice, then fragmentation may be the only option left, because we just would not have enough time to gradually push it off course. We would then have to just hope that the explosion would be large enough to either vaporize most of the object and scatter the remainders enough to either miss us altogether, or be small enough to burn up in the atmosphere if they did hit us. In 1995, Edward Teller, one of the original designers of the atom bomb, suggested a collaboration of ex-Cold War nuclear bomb designers from the US and Russia to create a 1 gigaton nuclear device that could be mounted on a high-powered space rocket. Such a device would be 20 times more powerful than the largest nuclear weapon ever exploded, the 50 megaton Tsar bomber created by the Soviet Union in 1961. and this would be able to vaporize a 1 kilometer asteroid or deflect ones with diameters of 10 kilometers or more. The problem we have with any of these and other theoretical methods is that for the immediate future they are just that, theories. If a large asteroid were to be discovered tomorrow and just a couple of months away from Earth, we currently have no really effective way of dealing with it. Just getting a launch mission prepared takes months, let alone what we would actually put on it. The Chelyabinsk incident has focused the issue surrounding the threat of extraterrestrial objects. But our Earth is in an interplanetary shooting gallery, and it is just a matter of time before a large asteroid is bearing down on us. Hopefully, before then, we might have some actionable plan to save us from going the same way as the dinosaurs when the last big object hit Earth. Thank you for watching. I hope you enjoyed the video, and if you did, then please thumbs up, subscribe, share and comment. And don't forget, we have other videos available which you may also find interesting on the link which is showing now. So until the next time, it's goodbye from me.